Wonderful students, my name is Kritika Khungar and I am going to teach you the instruction set of 8051 microcontroller. But before moving ahead to the instruction set, I want to tell you something about the addressing modes of 8051 microcontroller because it's more important to know about the addressing modes before going to instruction set. 8051 microcontroller provides a total of 5 addressing modes: immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, and indexed addressing mode. These are the 5 addressing modes of 8051. Firstly, we are going to tell you the immediate addressing mode. In this addressing mode, the source operand is always constant. There are two types of operands, the source operand and the destination operand. In this, the source operand is always constant and the destination operand will be preceded by a sign hash. This is the sign which is called as hash. Immediate data must be preceded with this sign always. When you see this sign, you have to predict that this is the immediate addressing mode. The addressing mode can be used to load the information into any of the register. We can use any of the register in it, whether it is R0, R1 to R7 or accumulator or B register or DPTR. These are some of the examples of immediate addressing mode. First is move A, hash 85H. This is basically the immediate data. Load 25H into A. A means accumulator. We are loading the 25H into accumulator. The other is move R4. R4 is the register. Move R4, hash 62. Load the decimal value of 62. This is like the, we can see this. We denote as like the decimal value of 62 into R4 register. We are loading the decimal value of 62 into R4 register. Then move DPTR. DPTR is a register, data pointer register. DPTR, hash 4051H. Load DPTR is equal to 4051. Means load this decimal value into DPTR. Move A, hash accumulator. Move the content of accumulator into accumulator. One address to another address. Next is direct addressing mode. There are 128 byte RAM in 8051. We all know that. This mode most oftenly used to access RAM location 30 to 7FH. Basically in this we use the RAM location 30 to 7FH. Some of the examples of direct addressing mode over here, we don't use any of the sign in this, we use all the register or everything directly. Move R0, 40H. Save the content of RAM location. We basically denote this as a RAM location. 40H and in this 56H, these are the RAM location. Save the content of RAM location 40H to R0. Then move 56H, accumulator, A. Save the content of accumulator in RAM location 56H. Move A, R4. Copy the content of R4 into the content of A. Basically, we are copying the register R4 into accumulator. Copy A, 4. If we put only 4, it means R4. So it is same as move A, R4. We denote it as copy R4 into A. Then we have this example, move R6, R1. This is invalid because we cannot copy the content of one register to the another register. We can only use either accumulator or we can use any RAM location. Keep in mind, in direct addressing mode, we can only move data from accumulator or any RAM location to the register or into the register. We don't move the data from register to another register. Okay. Next is register addressing mode. Register addressing mode involves the use of register to hold the data to be manipulated. We, as the name suggests, this is a register addressing mode and we only use register as for holding the data. Okay. Now move accumulator comma Ri. Copy the content of Ri into accumulator where I is 0 to 7. It can be any R1, R2, R3, R4, R6, R7, any of them. Copy the content of Ri into A. Move Ri comma A. Copy the content of accumulator into Ri. Means we are moving data from accumulator to any of the register or any of the register to accumulator. Addition. This is the addition. Add A comma Ri. Add the content of Ri to the content of A. Move dptr comma A. This is invalid because we do not use like dptr location in this register addressing mode. Next we have register indirect addressing mode. As the name suggests, it is indirect addressing mode. It means we use only the memory location or the address in this mode. In this we use @ sign for pointing the register in which the address is stored. In this mode, register is used as a pointer to the data. Means like we have a source operand and we have the destination operand. Always the operand which is connected with the sign @ there the address is stored in which we want to store the content of accumulator, or here like here we are moving the content of Ri into B. In this, the Ri is the place where the address is stored, where on which address we have to go to move the content into B. So if the data is inside the CPU, only register R0 and R1 are used for this purpose. In this we use only R0 and R1 registers. So some of the examples are move A comma @RI. When we see the sign of @ we predict that it is registered indirect addressing mode. So move A comma @RI. Move the content of RAM location whose address is held in Ri. Like the RAM location, its address is held in Ri, and we are moving that content whose address is present in Ri is into accumulator. Move @RI B. Move the content of register B in RAM location whose address is held in Ri. I have already told you, in this we use the sign @ for pointing the register in which the address is stored. The last but not the least is indirect addressing mode. In this mode, the data is accessed from the external RAM or on-chip RAM. Okay, this mode is also used when we want to access data from lookup table. Lookup table. Now, what is lookup table? Basically, when we want to store data into some LED look, like you have seen the LED on which we want to display hello. We want to this is like we have a LED like this, and we want to display hello on it. So there are some of the instructions over there in the lookup table from which we put on the instructions in the lookup table and go on with that. Or we have a 7 segment also connected with the microcontroller. Sometimes we want to display any letter over there. We also use lookup table for that. It is widely used in accessing the data elements of lookup table which are located in on-chip ROM memory in 8051. Example, move C A comma @A plus dptr. In this we have A plus dptr, the content of dptr register, and accumulator, which is a 16-bit data basically, and stored in accumulator. We are storing the data of A plus dptr into A. Here the address, the data is in the address of accumulator, and that is added into dptr, which is stored again into accumulator. And now you're thinking about what is C, move C. We have used instruction move C over here. C stands for the code memory. We are using the code memory. So for the reason we are using this instruction move C over here. In detail, move C, move X, these are the instruction I will tell you in details in my next video, which is on the instructions of 8051. Thank you for today, and a next video will be on the instruction set. Thank you.